Hi, I'm ABHIRAM.K, Assistant Professor, Department of Mechanical Engineering. Today we are going to discuss about liquid penetrant testing. Liquid penetrant testing is one of the common non-destructive testing methods used currently. Non-destructive testing method is one of the testing methods that we are going to test the test material without destructing the material. So, what is liquid penetrant testing? Liquid penetrant inspection is one of the oldest and most widely used non-destructive testing methods. It is also called as dye penetrant inspection. Penetrant testing can be applied to most of the materials including metallic and non-metallic objects. Metallic materials include aluminum, magnesium, titanium, cast iron, stainless steel, powdered metal products, copper, brass, bronze, etc. Non-metallic materials include ceramic, plastic, molded rubber, composites, and glasses. Penetrant testing can be applied on a porous surface. So, first we can discuss about the penetrant testing history. Penetrants first used in 1990s to detect cracks in locomotive parts. That is the first time that we used penetrant testing. Then the method was called oil and whiting. The method used is a dirty lubricating oil that was thinned with kerosene, followed by application of chalk coating which absorbs oil from cracks. In 1940s, fluorescence or visible dye was added to the oil. So here we heard two words, penetrant and absorbent. So what is penetrants? Penetrants are mixtures of organic solvents which are characterized their ability to wet materials, spread rapidly and penetrate into minute. So this is a penetrant. The second one is developer. Developer is a good absorbent material capable of drawing traces trapped in penetrants from the discontinuous back into surfaces. It also provides a light background to increase the contrast when visual penetrant is used. Generally, developer will be in white color or in pale yellow color. The main characteristics of developer is its absorbent characteristics. So, how we can test a material using LPI or liquid penetrant testing? There are several steps in this procedure. These are the main steps that is included in the liquid penetrant testing. We are going to discuss in details about this step. They are clean and dry the test object, apply the penetrant and let it penetrate, and this third one is remove the excess penetrant, then apply the developer, evaluate the indications and the post clean and of the test objects. These are the main steps involved in the liquid penetrant testing. So we are going to discuss about the each and every steps. The first steps is pre-clean part. The pre-cleaning is this can range from grinding and wire brushing to merely wiping the part with a rag moistened with the cleaner or remover. The surface need to be free of dirt, rust, scale, paint, oil and grease and be smooth enough to wipe off the penetrant without leaving residue. So the test material should be clean. That is the first part. We want to clean the test material. We generally use a cleaner for this one. The cleaner, we use cleaner and wipe out the test material for cleaning. The second step is penetrant application. Once the surface has been thoroughly cleaned and dried, the penetrant material is applied by spraying, brushing, or immersing the part in a penetrant bath. There are several methods we can apply the penetrant. These are spraying, brushing, or immersing this test material in the penetrant bath. Generally, the penetrant will be red in color, that is shown here. When we apply the penetrant will immerse into the cracks that we already have in that test material. The third step is penetrant dull. This is one of the important steps, very important steps in the liquid penetrant testing. The penetrant is left on the surface for a sufficient time to allow as much penetrant as possible to be drawn from or to steep into the defect. The penetrant dwell time is the total time that penetrant is in contact with the part surface. Dwell times are usually recommended by the penetrant producers or required by the specification being followed. The times vary depending on the application, penetrant material used, the form of the material being inspected, and the type of defect being inspected for. Minimum dwell times typically ranges from 5 to 60 minutes. Generally, there is no harm in using a longer penetrant dwell time as long as the penetrant is not allowed to dry. The ideal dwell time is often determined by experimentation and may be very specific to a particular application. The fourth step is excess penetrant removal. This is the most delicate part of the inspection procedure because the excess penetrant must be removed from the surface of the sample while removing as little penetrant as possible from defects. Depending on the penetrant system used, this step may involve cleaning with a solvent, direct rinsing with water, or first treating the part with an emulsifier and then rinsing the water. The fifth step is developer application. A thin layer of developer is then applied into the sample to draw penetrant trapped in flows back to the surface where it will be visible. Developers came in variety of forms that may applied by dusting or dry powder, dipping or spraying. When we apply the developer will help us to show the cracked parts by the color of penetrant. The sixth step is evaluation of indicators. It is critical to examine the part within the time frame designated in the written procedure. Length of an indicator or indication can grow over time as penetrant bleeds out, causing an acceptable indication to be rejectable defect. Length of indication is measured for evaluation. No, not length of the flow. Here, the two linear indications are rejectable defects. The round indication is relevant. In this figure, we can show that there is two linear indications and one round indication is here. The two linear indications are rejectable because that is the pseudo indication and only the round effect is considered. Post clean part. This is also one of the important steps in the LPI. The parts need to be cleaned to remove all developer after it has been evaluated. Interpretation of result. How we can interpret the results. If so, some spherical surface indications in the developer, we can conclude that is a casting porosity. If it is dotted lines, we can conclude that is a casting cold shut. If it is a straight continuous surface line, we can conclude that it is cracks, and ragged line of variable width, it will be hot tears. If it is multiple irregular lines, then it will be heat treat cracks. If it is interconnecting lines, then it is thermal cracks. If it is a broken line of varying width, then we can conclude that it is a lack of fusion, and if it is a continuous line in parts, then it will be a fatigue crack. Then, what is false indication? A false indication is an accumulation of penetrant caused by a drop of penetrant left on the workpiece. However, there are two conditions which may create accumulation of penetrant that are sometimes confused with the true crack and discontinuous. The first includes indications caused by poor washing, and the other one may created where parts press fit to each other. If a wheel press fit on a shaft, penetrant will show indications at that fit line. But these types of indications are easy to identify since they are regular in form and shape. Typical typical applications of liquid penetrant inspection. What are the typical applications of LPI? The first one is aerospace. In aerospace, typical components that are checked by these methods include turbine, rotor disc, blades, aircraft wheels, casting, forged parts, and welded assemblies. In automobiles, many automotive parts, particularly aluminum casting and forging, including pistons and cylinder heads, are subjected to this form of quality checks before assembly. In railways, LPI to detect fatigue cracking is also used for the regular in-service examination of the bogie frames of railway locomotive and the rolling stock. In tool and dies, field dies, drilling rays, drill pipes, casting and drilling equipments inspected by this method. In inspection on reactors and tanks, tanks, vessels, reactors, piping, dyers in the petrochemical industries are tested by LPI. What are the advantages of liquid penetrative testing? First one is easy to perform. If easy to perform means even the complicated surface and shapes we can easily perform the LPT. It is very inexpensive. No expensive cameras or equipments are required for the performance of LPI. Can be used to inspect large areas quickly. Then the findings, that means the defects identified by these methods be can be seen visually on the surface of the material and can show the dimensions of the defect. The material flexibility, that is another advantage, can be used on a variety of materials including ferrous, non-ferrous, conductive, non-conductive, and magnetic or non-magnetic materials. There are some disadvantages also for LPT, that are limited findings. Only defects, cracks on the surface is only seen by liquid penetrant testing. The next one is porous materials can be inspected with the dye penetrant. We cannot inspect the porous material using dyes. Third one is dirty surfaces can be inspected with the dye penetrant. Dye penetrants won't work on surfaces that contains paint, oil, dirt, rust or any other similar kind of obstructions. Direct access to the materials is required. And the another limitations is there are several steps in the inspection process, each of which could impact the quality of finding. And another one is cleaning is required both before and after the inspection. Before to prepare the surface for the penetrant and after to clean the penetrant of the surface. And the final limitation is the chemicals are involved. Since the chemicals are involved, inspectors must follow protocols to handle and get rid of them, and these chemicals could produce hazardous or flammable fumes. So with this I am ending this presentation. Hope you all get a small idea of what is liquid filter testing and its advantages and applications. Thank you.